Your company's network just went down. Nobody can print. Nobody can reach the internet. Nobody can access the file server. Panic at the help desk. But here is the thing. If you know what each network device actually does, you can trace the problem in minutes instead of hours. And that is exactly what we are covering today. Welcome to Chapter 2 of the CCNA, Network Devices. Everything you see in a network, from your laptop to the router at the edge, falls into one of a handful of categories. Once you know those categories, you can look at any network diagram and immediately understand how it works. So let us start with the basics. What is a network? At its simplest, a network is a system that connects things so they can share resources. A railway connects cities. Your blood vessels connect organs. And a computer network connects devices so they can share data, printers, servers, and the internet. Two key terms you need to know right now. A node is any device connected to the network. Your laptop is a node. Your phone is a node. Even the routers and switches that connect everything are nodes. A resource is anything shared over the network. A web page, a printer, a file on a server, an online game. Now, networks come in two main flavors based on geography. A LAN, local area network, covers a limited area like an office or a home. A WAN wide area network spans large distances, like connecting offices in different cities. The internet itself is the biggest WAN of all. Now let us talk about the devices that make up a network. First, the devices that use the network. Clients and servers. A client is a device that accesses a service. A server is a device that provides a service. Your phone streaming Netflix? Client. The Netflix server sending the video? Server. Your laptop opening an Excel file on a company server? Client. The server hosting that file? Server. Here is the twist. Almost any device can be both. If you share a file from your laptop to a colleague, your laptop is acting as a server. If your colleague sends you a file, your laptop becomes the client. Both are clients when they browse the internet. Clients and servers are not specific types of hardware. They are roles that devices play depending on what they are doing at the moment. Now, clients and servers need something to connect them. Enter the switch. The switch connects devices within a single LAN. Every PC, printer, security camera, and server in an office connects to a switch. Switches typically have 24 to 48 ports. Physical connectors where you plug in cables. The switch does not participate in the conversation between devices. It simply makes sure the data gets from one device to another within the same network. But what if you need to connect to another network? Like the internet? For that, you need a router. Routers sit at the edge of a LAN and connect it to external networks, the internet, or another office across town. While a switch connects devices within a LAN, a router connects LANs to each other. If you are at home, you probably have a wireless router. That device is actually doing 4 jobs at once: routing, switching, providing Wi-Fi, and running a firewall. It is a Swiss Army knife for small networks. But in a large enterprise, you need dedicated devices for each role. Which brings us to the last device, the firewall. A firewall sits between your network and the internet, inspecting every piece of traffic that enters or exits. It makes decisions based on rules. Allow this, block that. Your PC has a host-based firewall like Windows Defender, but a network firewall is a separate hardware appliance that protects your entire network, not just one device. It is the guard at the gate. So let us recap what we covered. A network connects nodes so they can share resources. A LAN covers a limited area. A WAN spans large distances. Clients access services. Servers provide them. Switches connect devices within a LAN. Routers connect LANs to external networks. And firewalls protect the network by inspecting and filtering traffic. Know these roles, and you can look at any network diagram and understand exactly what is happening. That is the foundation the rest of the CCNA is built on.